All right, I want you guys to take the next 30 seconds to go ahead and literally turn with your spiral to the people in your group and say, what'd you guys get for the first, the second, the third, the fourth? Let's see if they agree. Hey, just watching your group out here. You guys already checked that. All right, here we go. Thank you. That was 30 seconds. So, coming back to the front, let's see how you did. It's not that you got it perfectly right. Let's just see what you did get right. And if not, if you got stuck, hey, can you guys grab out a colored pen? We're going to grade our homework in a second anyway. If you got stuck, you can write yourself a quick reminder. Because some of you got stuck, and that's okay. Let's talk about it. Colored pen now. Alexis, do you have a colored pen? Oh, yeah. Good. Colored pen. Standard form. Ready for my hint? Ready for my clue before we talk about the answer? For standard form, if I were you in a colored pen, or if you were gone yesterday and you're seeing this for the very first time, standard form, you want to think descending powers. You want to think descending powers. When you have, guys? Danny, you're not talking to people as you're sharpening your pencil, okay? So go get a seat. Go get your seat. Quietly. Okay. Descending powers. Guys, how many terms are there in this expression? 4. Good. So we have 1 here, 1 there. We can look at the addition and subtraction to separate. We have 4 terms. Everest, we're doing good? 4 terms? Awesome. Descending powers. So who has the strongest power, or the strongest, what we would call degree? 15. Well, the 15x cubed. Read the whole guy, the whole term. Okay, so 15x cubed has the strongest power, so he goes first. Descending powers. So the strongest guy is 15x cubed. He should have been your first guy. All right, what's the next one? Oh.
X squared.
Yeah, the x squared term, and literally, he's just x squared. Now hold on, pause. What sign, positive or negative, was before the 15x cubed? Positive, so I kept him a positive number. What sign is before the x squared?
Positive.
So I'm adding a positive x squared. Okay, who's the next one? Descending powers. Who's next?
4x.
4x, good, because it's 4x to the 1. What sign is in front of him? Positive. So plus, I'm adding a positive 4x. And then what sign is before he's the last guy, right? 7. So minus 7. We have to make sure that we keep the signs with the terms, because if we start rearranging and we don't keep the signs along, we're going to mess it all up. Standard form, does it make sense now?
Yes.
Okay, and if you didn't get it right the first time, that's okay. Did you write the clue down? Decreasing powers. That's the clue for standard form. Decreasing powers. Now wait a minute, why did the 7 go last? What power does he have?
Negative.
Because the x is not there, so it's the 0 power. Good. Now, I keep on talking about power. Didn't we talk about power yesterday? Horsepower in cars, magnitude in earthquakes. The polynomials, that's the word degree. Horsepower in cars, magnitude in earthquakes, degree is the power of a polynomial. Now, we talked about just now the powers of, ready, my blue pen is out again, it's for hints. We talked about the powers or the degrees of each term. So technically, when I say descending powers, what I mean is descending degrees. And we think of the terms separately. So the degree of this guy was 3. The degree of this guy was 2. The degree of this guy, even though it's not, it's 1. And then this one was the weird one because his degree was 0, right? Because there was no x. Now, when we're talking about the degree of the entire polynomial, you have to remember that the highest one wins. It's the highest. It's not like adding them all together from the entire thing of all the different terms. It's the highest terms degree. Yesterday, we were talking about like a law firm. It's silly, but I used to watch this show called Suits, and it finished this past summer, yada, yada, yada. But they kept on changing the name on their law firm, and it was who was the managing partner, or who was the name partners. On law firms, usually, whoever's name is on the building is the top dog, is the head guy, right? Kind of, yeah? Whoever's name gets on the corporation or the law firm is the top guy. Kind of like this. Who gets to choose the degree? Who gets to choose the power? The highest guy does. So who's the highest guy out of all of these? Nice thing is, shouldn't it be this one? So, what's his degree, guys? What's his power? 3. So the degree of the entire polynomial should have been 3. I'm not adding them all up. I'm thinking of them distinctly, and I'm saying who's the highest, who's the stronger, he or the strongest. He gets to keep his degree. He gets to keep his degree. The strongest. I need to think of something better than the law firm. That's just the one that popped into my mind yesterday. I'll try to keep thinking about it. Something where there's a lot of different people or a lot of different things, but yet only the strongest or the highest or the top one gets to choose or is identified for the entire business or corporation or team. I don't know, I can't think of one. Let's go to letter C though for right now. Letter C, I have my blue pen again as far as a hint or a clue. Remember, when we're circling names, we have to think of how many terms. Because guys, don't each of these have to do with how many? Monomial, how many?
1.
Binomial, how many?
2.
Trinomial.
Tres.
Yeah, you can say tres, right? For triangle, 3 sides. So monomial 1, binomial 2, trinomial 3, but why am I circling for this one? And a lot of you, why am I circling polynomial? It's not 1 or 2 or 3, it's 4. Yeah, now technically all of these are polynomials, but if there was one, we wouldn't say polynomial, we'd say monomial. If there were 2, we wouldn't really say polynomial, we'd say binomial. If there were 3, trinomial, but there's 4, so polynomial. Best way to go. Last but not least, guys, if you notice, these were the questions being asked in homework, right? Leading coefficient. If you have, or if you watch a movie and there's a leading role of a play, of a movie, an opera, or whatever, if there's a leading role, what is that? Who is that?
Star.
The star. Yeah. So from everything that we've talked about with this polynomial, who is the star? He got his degree put in for the whole thing. He got put in front. Yeah. Yeah. So the leading coefficient, who's the star? The 15 is the star. Now, is he necessarily like the most important part of that? Well, no, but out of all the coefficients, he's the leading one. He's the beginning one. He's the starting one, right? Now, leading roles aren't necessarily which one shows up first in the movie. That's not necessarily the lead. It's not who shows up first, but it is the one that ends up being in the most important place, right? There you go. That's homework. That's what it was last night. Homework was that page, 362, but the earlier problems, 5 through 20. It was that page. But the earlier problems, 5 through 20. Turn there, because some of them are evens, and we need to go grade them real fast. But do you guys have your hints or your clues? Maybe I should write a hint for leading coefficient. Leading, he's the star. You can say the coefficient.
Can I take a picture of the homework?
Yeah. The star is the one with the highest degree. All right, I'm pretty sure it's not my phone. I'll go double check it's not, but if it's not, someone's phone needs to get turned off. Highest degree, the leading one, the star, that's the leading coefficient. Maybe it was mine. Did I not turn it off? Oh, no, I did. It wasn't mine. Awkward. Turn your phone off. Oh, wait, no, sorry, not notes. We have to go grade. My bad. My bad. Okay, so homework last night, if you need to write it down, it's page 362 or section 7-1, 5 through 20. Section 7-1 or page 362, 5 through 20. Did you get it, Armando? Okay? Does anybody else ask the answer? Needs to write this down. I know today Jerry and Sean. Okay. Guys, go ahead and grade real quick. Number 6 was 4. Number 8 was 0. Number 10 was 6. Number 12 was 11. If that was too fast, just look at it. You're good. Number 14, 16, 18. Do you see how they were ordering it in descending order? The 12th degree and then the 11th degree. The 3rd and then the 1st and then the 0. And this guy didn't even have a second. That guy didn't have anything else besides 12 and 11. I think the next one was talking about the degree, the strongest guy's power, then the leading coefficient, the number of that very first star roll or star place, and then how many terms binomial. Let's see if those answers make a little more sense now. There were some weird numbers that showed up, like the square root of 7. That's all right. No homework. You're ready to go for this, huh? Good. Good.
Whoever.
All right, as you guys finish grading, I have it open here on the screen. So you can look at the directions along with any ones that you got wrong or any ones from last night. Are there any of these ones, 5 through 20, let me zoom out, that got a little tricky that you want us to talk about? Remember, I did every day after school, we said during lunch to if we run out of time. Yeah, keep it on the list. Let me see if I can get some. Then we can show me later. Okay. Out of the entire homework, does anybody have what they thought was like one of the trickiest ones of 5 through 12? Andy? 18. Okay. Well, okay. We'll look at that one. Good, good, good. But first, anything that was really tricky here? Like, if you had to pick one, Adrian, what do you think?
Number 8.
Number 8?
Yeah.
Well, he's kind of weird. Melanie, do you have another one?
I just think you like for number 12, it like wasn't 10.
Okay.
It was 11.
Yeah. So let's look at number 8 and number 12. Not that, like, there were other tricky ones, but why do you guys think that Adrian thought number 8 was tricky, or could have been tricky for some? Look up here, everybody. Eyes up here, eyes up here. Hannah, eyes up here. Number 8, why was he tricky? Doesn't have a variable. But wait, that's the key. He doesn't have a variable. So if we're looking for the powers, right? His degree is 1. His degree is 4. His degree is 2. He doesn't have one. So, 0. Yeah, 0. Good. So Adrian, you're right. It was totally tricky because there was no variable there. No variable there means degree of 0. You guys should see how many times a day it looks like I'm just talking to the smartphone. Number 12, though, why was he tricky too?
Or has or exponent.
Yeah, that's a great explanation. Because you see the 4, you see the 6, and you get used to just adding them together, right? 2 and 4, a degree of 6, 8 and 1 makes 9. This R has an understood 1, the same way that this G has an understood 1, and this T has an understood 1, and this X has an understood 1. We have to count these guys when we're doing degrees. So 4, 10, 11 would be the strength. And guys, this is something that you didn't see in the opener. Because in the opener, it was just X's to degrees or to exponents. But remember, if you have a more complicated monomial with more variables, to get the power, to get the degree, you have to add them all up in one monomial or one term. Because they all contribute to the power of the degree. Cool?
Yeah.
But every time you see a variable without an exponent, like the G, like the T, like the X, like the R, What's the understood exponent again?
Very huge.
1. Understood exponent is what again, Swanson?
1.
Got it. So we have to add it in. Now, we have more than that, though. And Andrew Bosch already got us a question in the second one, number 18. You guys can peek and see if there's something else that you want to see. But let's look at number 18 really fast. Our goal is to rewrite just like the opener, to rewrite it in standard form, identify the degree, the leading coefficient. I think that's it. Oh, and then name it. So name it, leading coefficient, degree, and then standard form. All right, standard form. What was the clue that I said in the opener you were supposed to write in a colored pen? Biggest to smallest or descending in powers. So, descending for number 18. Who should go first? Good, the 4th degree one, right? Because out of all of them, he's the strongest. So it should be 3z to the 4th. What should go next? Then, yeah, the cubed one. Then what should go last? The 5z. I know, it's catching up. All right, so standard form. That's a check. Andrew, good so far?
Yep.
Perfect. Now degree. Well, what was my hint in the opener that you wrote down? The lawyers in the law firm. Whose name is on the building? The main guy. So who's the main guy?
3.
And what is his degree? 4. Okay, so the degree of the whole thing is 4. He gets to choose the degree, and he's going to choose himself every time. I'm selfish, but that's okay. He's allowed to. And not everybody whose names are on the law firms are selfish people. Sometimes there's actually like these huge leadership conferences and stuff, that sometimes the best bosses are the ones that actually like get down and relate to their employees. There's this whole thing, lead by serving, and it's not even like a Christian thing, it's a secular leadership. Anyway, super crazy. Maybe Jesus did know his stuff. Coming back. So we have descending order. We have the main guy. His degree is what's attached to the whole thing. And then we need the check. Leading coefficient. Wait, we just figured out the star, didn't we?
Yeah.
So what was his coefficient?
3.
3. So the leading coefficient is 3. Right? And then classify the polynomial. What's his name?
Polynomial.
Well, but how many terms?
3.
Okay, so think your triangle. The best name for him is going to be a trinomial. What? Sorry, I had to do cursive because it wasn't showing me my letters. Trinomial. Does that make sense? 3 terms? Try.
Yes.
Got him, coach.
Done.
Yes. What would his name be? Mine. Yeah, he only has 1. So remember, we look for those additions to tell us how many terms. This guy had 1, 2, 3. This guy only has 1 lump. This guy's another monomial, but everybody else has more than. So we have a couple trinomials, some binomials. Oh, trinomials. Anyway, ironically, none of those were just polynomials. They all had special names because it was 3 or 2 or 1 term. What? Andrew Swanson, keep some of those random words in your head because they're not helping us in class. All right, here we go. So, Chapter 7, Section 1, Part 2. This is the key. If you guys wrote down notes yesterday, which you should, I went around, we did a note check, made sure everybody is keeping track. It's easy, 100%. You have your notes that you're taking every day. We already started Section 7.1, and maybe you guys wrote down the essential question, and maybe you didn't. But the essential question in 7.1 is actually in the book. Let me look at the question. Bring it in. Because we already did this yesterday. The essential question is, how can you add and subtract polynomials? We'll check it. Yesterday was just getting us all the terminology. It was just letting us know how to name them, or how to say how strong they are, or to talk about leading coefficients. It was all about the particulars, the logistics. Today is all about how you actually do what you're supposed to do, add and subtract polynomials. And the nice thing is, guys, it's as easy as combine like terms. It's as easy as combine like terms. Easy as. That's crazy. That was our warm-up yesterday. We already know how to combine numbers. That's something you learned in pre-algebra, and hopefully you did a little bit in algebra 1. Okay? This entire chapter is going to be like, hey, what can we do with polynomials? We're going to start with adding and subtracting. We're going to move to multiplying. Probably not dividing, exactly 20 minutes. Then we're going to move to what we call factoring. And factoring, which there'll be a test before we do factoring. But factoring is probably the single most important thing you learn in Algebra 1 for future math. So we're building. Girls, real quick, can you just hold up your hair for me real fast? Because we have some AirPods in. Hold up. Real quick. Love you all. That's just the thing that happens. Alright. Mouthing the words to the song.
I'll hold my hair up too.
Okay, here we go. I agree, I know. Sometimes math is boring, but hold on. You gotta focus. Here we go. Oh, guys, you do it too. You do the whole like sweatshirt thing. You put your hood on. Okay, I'll include you too. Anyway, here we go. Here we go. We got it. Adding and subtracting polynomials, right? Adding and subtracting polynomials. Here's what I need you guys. Remember how in our warm-up today, I got my blue pen and I gave us some hints, and with the hints we were able to rock the whole descending order standard form and highest degree and the star roll coefficient, leading coefficient. Can I do the same thing with this? You guys ready? Okay. Distribute. Here's my hint. It's actually going to be for all of today. If I can spell distribute. That messed up. Distribute away the parentheses. Distribute away the parentheses. Now, why am I using the word distribute? Why am I using the word distribute? I thought distribute is when you need, we did it yesterday. Distribute is when you need to, be right up here. Oh, whew, sorry guys. This is some overwhelming math in the calculus. Let me get rid of all this. That's craziness. Something that we call function notation and derivatives. Ironically, something that the field of economics, like stock markets, they use a lot of derivatives. But anyway, show me that. If you saw, why does this need distribution? Because we're trying to figure out why did I use the word distribute? Where's the distribution? Yeah, the parentheses. And why am I distributing? What's in front? And when there's a number next to a parenthesis, it always means to do what? Multiply. But I have a plus. And since I have a plus, don't I have to multiply the 2 to the and the, got it, I have to distribute. Right? And after I distribute, I'm going to get 2 times x plus 2. I distribute across additions and subtractions. Now, why am I saying distribute here? What are you distributing to do?
What?
To get the parentheses away. Oh, hey, what happened when we distributed? What's gone?
Yes.
Exactly. So check it. Don't we have some parentheses we really wish we didn't have? I have some parentheses I really wish I didn't have, don't you? So how do we get rid of them? What's outside if there's not a number isn't understood just not at 1. So I can throw in an understood 1 to both of these, and I distribute away the parentheses. Now the nice thing is, if there's just a positive 1 in front, what's positive 1 times anything? Yeah, so positive 1 times 5 is 5. Positive 1 times negative 100 is still negative 100, yeah. So what's positive 1 times b? Well, still b. Positive 1 times negative 10. Or I should say positive 1 over a minus times 10. And I would distribute again. Distribute away the parentheses. So what's going to be the next term, guys? plus 4b, and what's the next or the last one? Minus 3. Going across subtraction, and 1 times 3 is 3. Oh, it's the opener from yesterday. Combine the head terms. B's go with B's, and non-B's go with non-B's, right? Now, if I were you, I really, really, really appreciate color coding when things get way more complicated. Like, find your B's and find your non-B's. But here's the place where most mistakes will happen. Focus. Here's the place where most mistakes will happen. Remember how I said today when we reorder those polynomials to be in standard descending form? You have to make sure the sign goes with it. We have to make sure the sign goes with it. If you guys don't notice, the 10 has a negative and the 3 has a negative, you could get in some awful big trouble in the sense of making the whole problem wrong, right? So be very, very, very careful with the signs. And some of you, it might be helpful to remember that subtraction is always adding the opposite. The 10 is a negative number. Subtraction is always adding the opposite. The 3 is a negative number. Just in case, it makes it a little bit easier in your brain because, guys, I have calculus kids that do fast math, and they've done this huge problem that's taken up an entire board, and they make a mistake with positives and negatives. It's so easy to do. So we're just trying to perfect it now so we never have to worry about that. So, how many B's do we end up having if we combine the purples together?
Negative 3. Oh, 5. Negative.
5B, because that has an understood 1, right? So a positive 1 and a positive 4 is a positive 5B. But what does my coefficient? I can always put a plus if that's easier, but I have a negative 1.
Negative 13.
So that's one way of writing it, but most of you will like the other form of minus 13, which is probably the best way of writing it. But we got it, right? Like, this isn't bad. Hey, this is going to be on the test. These are the ones that hopefully will not make mistakes on and will ace. So you guys, can you go ahead and take the second example, distribute away the parentheses, combine the like terms, and let's see if you can get that perfectly simplified answer. Take your time. Distribute away the parentheses. Combine the like terms. Show me that you got it. If it's not bad, then prove it to me. And they have ideas. I've already seen 2 good answers. Take your time, though. Take your time. Distribute away the parentheses. Combine the like terms. Adrian, let me see. We're supposed to do the next example. Come on. Show me if you do it. Show me if you do it. Totally thought you would have it already. Got it. Come on. in my parentheses.
Yeah.
Hopefully this part, not many people got lost on because when we distribute the 1, everything stays the same. But some of you, it might be helpful to remember that when we distribute a 1, isn't it 1x squared if there's nothing else?
Yes.
And then minus 1x if there's nothing else, and then minus 2. And then plus 7 times 1 is 7x squared, and then minus 1x. Not that you have to write the 1s, but for some of you, it will remind you of how or what you need to combine. Now, if you went through and tried to change all your subtractions, you could have said, like, hey, remember, subtraction is adding he's a negative number, he's a negative number, and he's a negative number when we combine. You guys go tackling the x squared first again?
Yes.
How many x squareds total if you combine the like terms? 8x squared. Now remember, there are a few of you that are remembering all those exponent properties from last chapter. And you're like, how many? Well, hold on. If I was to say that you had negative 1x plus negative 1x, how many x's do you have? Do you guys all get to negative 2 x's? We don't change the exponent of the x. The same way we don't change that, we don't change him either. Yesterday, remember I was talking about the guy who was teaching his niece algebra, and she's 5 years old? And he was just saying stuff like, if you have 5 apples and 1 more apple, 6 apples. If you have 4 oranges and 2 more oranges, 6 oranges. If you have 5 x's and 2 x's, 7 x's. She did math, and she didn't even get confused. She knew it was, hey, when you combine like terms, it stays the same. So, how many x squareds? 8, and that's it. How many x's? Negative 2, and that's it. You could say plus a negative 2, that's totally fine, but in a second we'll probably just make it minus because it looks nicer. But guys, I left someone out. Who else do I have? I still have my negative 2. That's adding. The essential question is section 7.1. How to add and... Oh, okay, we need one more page. The nice thing is, though, it starts the same way. The nice thing is, though, it starts the same way. So guys, check it. Subtracting polynomials. Looks a little bit harder. Maybe there'll be p's or k's instead of x's, but still the same idea. Adding the opposite. If we're subtracting polynomials, guess what? We're still technically, check it. We're still technically distributing away the parentheses. And then combining like terms. We're still technically distributing away the parentheses. We just have to be really, really, really careful of the negative. That's the long story short. We're still distributing away the parentheses. We just have to be really, really careful of the negative. And if we're really, really careful of the negative, we should be fine as long as we just go, once again, very, very carefully. Now, if you guys finish writing down these notes, remember you do have homework up here on the board. We do need to get through these 2 examples before we're done for today. But some of you were a little worried about today's schedule because it is weird. So I'm getting up here really quickly so you know what's coming. Everything is basically like 2 minutes shorter, but then that kind of throws the whole schedule off. I know, crazies. You're all waiting on me. Hold on. Okay. Woo! There's a schedule if you guys need it. How would we distribute away Just working all together as a class, how will we distribute away the parentheses? What is in front of this guy? A positive 1. All right, focus back on it and finish off these 2 examples. When we distribute a positive 1, don't we get a 1p squared plus a 1p plus a 3? Because 1 times 3 is 3. That was the same. It was a positive 1, not much changed. But over here, wait. Isn't subtraction adding the opposite? It's not a positive 1. What's in front now? When you have subtraction, there's a negative 1 in front that needs to be distributed. So we have to distribute a negative 1. And guys, what happens when we multiply something or a quantity by a negative number to the sign? It's supposed to switch. It's supposed to flip. So negative 1 times negative 4p squared, isn't that going to be a positive 4p squared or plus a positive 4p squared? Excuse me, sit. A negative 1 times a negative p, isn't that going to be a positive p? And a negative 1 times a positive 3 is a negative 3. On Monday, we'll see how, you guys might not have realized this bad math kills, what on earth is going on. We're learning today how not to kill a sequence. We'll talk about it Monday, we'll see what's going on. Even my calculus kids, they make mistakes when distributing negatives all the time because they go too fast. Now guys, at this point, we would just start pairing up, combining my terms. We still have a whole other minute, focus. I was going to keep you later, and then you'll be able to turn to class. No need tardy notes. Come on. I have a 1p squared and a 4p squared, which is going to make a
5p squared.
I have a 1p and a understood 1p, right? And then I have a 3 minus, wait, what happens to 3 minus 3?
0.
Oh. Okay. Sometimes when you add polynomials, you might end up with 2 trinomials made a binomial. That's all right. That's how the math works. So how are we going to get rid of the parentheses on this guy? Distributing the positive 1, right? Which keeps in the same and keeps in the same. But what's going to happen over here? What's going to happen to the signs of each of these guys? It's going to change. It's going to flip. And when we change, we just have to be really careful that when we go ahead and combine. Oh, wait a minute. We can't combine those two. Be careful. Sometimes there aren't even things to combine. So we would end up with, pause. We have to end up with, there are no other cases, so we rewrite him. There are no other case, so we just rewrite him, but we do get to combine the 5 and the 6 to make 11. Guys, your object in homework, take a picture of it on the way out the door is just to add and subtract polynomials. Bye, guys. Go carefully. Don't kill seals, even though you'll be doing it without meaning to. It's on the board if you need it.
No, I'm
You didn't mess up? These eyes like an ink.
20 minutes. 20 minutes.